Here we have a problem on logarithm. That is, we have to solve this logarithmic equation for x. Okay, in this given logarithmic equation, on the left side, we have addition of two logarithms. Whenever we have addition of two logarithms, what we'll do is we'll be trying to use product rule. But if I want to use the product rule, a condition has to be met. That is, the two logarithms which are in addition must have the same base. So that I will be able to use a product rule. So here I cannot use a product rule. Okay, so what I'm going to do is, okay, first let me write the given equation log x to the base 2 positive log x to the base 4 equals to 6. Okay, so what is the coefficient of the first logarithm? I mean, what number do we have in front of the first logarithm? Actually, we don't find any number. We can assume there is number 1. So now I'm moving this log x to the base 2 to denominator. So whenever I move a logarithm from numerator to denominator or denominator to numerator, I have to switch the base and argument. So when I switch the base and argument over here, then it will become log 2 to the base x positive. So the same thing, we can assume there is 1 over here. I mean, the coefficient of the second logarithm is 1. I am moving this logarithm to the denominator. Then I have to switch the base and argument over here. So log 4 to the base x equals to 6. Okay, so 1 over log 2 to the base x positive 1 over log, and this 4 can be written as 2 square to the base x equals to 6. So here the next step, 1 over log 2 to the base x positive 1 over. So here the argument is exponential. Whenever the argument is exponential, I can use the power rule of logarithm. That is, I can move the exponent over here in front of the logarithm, and it has to be multiplied by the logarithm. Then I'll be getting 2 times log 2 to the base x equals to 6. Okay, here if I want to add two fractions, the denominator must be same. So here the denominator is 2 log 2 to the base x. Here it's just 2 log 2 to the base x. So if I want to get the same denominator, I need 2 over here. So for that, what I need to do is I have to multiply both numerator and denominator of the first fraction by 2. So then I get, so now the denominator is same, 2 log 2 to the base x, 2 log 2 to the base x. Here the numerator is 2 times 1. So 2 positive 1. I can take the common denominator, that is 2 times log 2 to the base x equals to 6. So here 2 positive 1 is 3. 3 over 2 log 2 to the base x equals to 6. Okay, now what I'm going to do is I'm going to move this log 2 to the base x to numerator. So when I move this log 2 to the base x to numerator, I have to switch the base and argument. Then in my next step, I'll be getting 3 times log x to the base 2 equals to, 3 times log x to the base 2 over 2, because we have 2 left in denominator. I have moved only log 2 to the base x to numerator equals to 6. Okay, to get of this 3 over 2, I multiply both sides of this equation by 2 over 3. So when I multiply both sides of the equation by 2 over 3, this 3 will cancel, this 2 will cancel out, and 3 goes into 3 one time, 3 goes into 6 twice. So I get log x to the base 2 equals to 2 times 2 is 4 on the right side. Okay, so to solve for x, I have to get rid of this log to the base 2. Actually, this is logarithmic equation. If I convert this equation to exponential form, I'll be getting the value of x. To convert this equation to exponential form, I have to move this log to the base 2 to the other side of the equation. When I move this log to the base to the other side of the equation, I have to ignore this logarithm. I have to consider only the base 2 on the other side. The value which already exists on the other side will become the exponent of this base. And I have x left in the left side. So x equals to 2 to the 4th power, this 16. So I have solved for x. The value of x is 16. The correct answer choice for this question is option A.